Straight on to the first presenter, who will be Nina Bargisen, who's the is the Director of Technical Evangelism at Kentik, where she focuses on supporting the company's service provider users, drawing from her long experience as a peering coordinator and network engineer. Nina served on program committees and IXP boards, and she's co-chair of RIPE's MAT working group. And prior to Kentik, Nina built the network for Subspace and played an instrumental role in securing the delivery of Netflix streaming traffic in EMEA. So please join me in welcoming Nina to the stage.
Hello, hello, and thank you so much for your patience in waiting for me to get on the stage. Must have been a long wait, all right? Today, I am going to be talking about fighting DDoS at the source. I think we are coming a good way on fighting DDoS, but it is an ongoing issue. I don't think there's a lot of new stuff I'm going to be talking about, but I'm going to give you a recipe for those of you who run a network where it would be a suitable approach. The work is based on some work by my esteemed colleague, Doug Midori, who, as you all know, is around looking at what can be done on the internet, what is happening on the internet, along in collaboration with one of our customers. So first of all, just a quick recap for those of you who may have forgotten. It was a good night last night. DDoS attacks continue to plague, and one of the most common ones is the reflection attacks. Quick recap on a reflection attack. It is basically you have an attacker who have infected a lot of machines on the internet and will send requests with a spoofed source address to servers who will reply to that request. So that be DNS servers, NTP servers, mail servers, whatever kind of servers that can get a request and will reply to the source address of the request. That then means that the target address, the spoofed address, will be overflowed with all of the replies. Sometimes the replies will be in much larger packets than the requests are, which means that it will not only be a reflection attack, but also an amplification attack. So way more traffic than coming into the servers will overload everything. One of the largest reflection attacks that has been recorded on the internet, as far as I could do on the research that I was doing, was to Google Cloud in 2017. Anybody can feel free to correct me if I'm not wrong, if I'm wrong in this one. And if I'm not wrong, please don't correct me. So this attack originated in Chinese networks. And the attacker spoofed 167 megapackets per second to that was sent to 180,000 exposed servers, so servers that were not patched or would just accept the request. And at the peak of the attack, you were seeing like 2.5 terabits of traffic going towards the destinations of the attacks. These numbers are based on a news article I found on the internet and Google's blog, so you can go read all the details there yourself if you want to. So what can we do with these attacks? Well, one is, can we do anything about the servers so that they will only reply to real requests? That one could be a little bit difficult because it's a packet that comes with request. We can try and implement techniques into the network, like to validate whether the source IPs of a flow is the correct one. And finally, we can go and talk to people about people that we identify are allowing the spoof traffic. So I'm not going to talk about the first one. It's way beyond my expertise to think about how you can harden servers. Somebody else will tell you stuff about that. The second one, implementing source IP verification, has been around for many, many years. BCP 38 I remember one of the first community work I did in the RIPE region was a BCP 38 task force in sort of 2003 or 4 or something like that, like 20 years ago. And we were describing exactly what is also the case today. It's not implemented all over, and there are a number of reasons why. So we can have a look at what is it that you can do, and why is it an issue for you for everybody to implement this? Because it's like, oh, just go out, implement BCP 38, and the job is done. But it's not. So the most efficient one is the strict reverse path forwarding, saying, hey, you can't send traffic into this interface unless I am sending traffic from your source address out this interface. That works if you're just connecting to a customer who has that one single connection. So we could implement that on all customer interfaces who do not have a redundant setup. But that is a limited amount of interfaces, but it can be done. Well, we can solve the multiple path solution by using what's called feasible reverse path forwarding. So we look at, do I, on this device, have any path to this address? And then I can allow the traffic. All problem solved, right? Except if the network in question that you're connecting to have started to do traffic engineering and withdraw some prefixes here and there, and suddenly you have a high risk of black holing. So a lot of people choose to not do that either. Finally, you can do it manually or with all the automation we have these days. It shouldn't be really hard. But again, it turns out people are not really doing it. By adding access control list, where you just manually say, only these packets are allowed. But that's a lot of maintenance. It's secure if you do it properly, but it's easy to make mistakes. And does the customer have a lot of prefixes? It's like, that's a lot of work. It's gonna use resources on my routers. So a lot of people are not doing that either. So because of these good or less good excuses on not doing this technical implementation, we will urge me, my colleague, and in particular one of our customers who have given us this method and allowed us to use it as a presentation. How can we identify our downstream customers allowing spoof traffic? And what are we going to go and tell them? So we need to talk to each other. But first, we need to figure out which customers should we talk to. So in short, I mean, I could leave you this slide and then walk away and say, here, you got it, but I'm going to go into detail how you do the 1 and the 2. But it is a customer of ours who is doing this on a regular basis and calling his customers and say, hey, help out. First you look at spikes of traffic to a large, so you look for patterns where a customer will send a lot of traffic to a large number of IP addresses on the ports that you know are being abused for these kind of traffic. And then you will identify, oh, this customer is doing something, and then investigate, is this customer, the source addresses that are coming from this, that are the sources of all of these packets, do they make sense? That's in short the method. So in whatever favorite NetFlow tool that you have, because this is what you need, you will need to look at NetFlow to do this. Run a query where you're obviously only looking at traffic from external sources of your network, packets that are going to the reflection ports, and there's a list of those. And then look at packets per second and look at the unique number of destination IPs. And group that query by your customers and by your device, so you know which device is this happening on and you know the customer interface. There, this is the result of this kind of query, and you can see you have a list of customers over there, and you see, oh, there's a spike. This is something suspicious. I'm not saying that this is for sure an application at a reflection attack, but it is a sign that something might be happening. And we notice, okay, this is customer B, and we can then look at the table and the results that they're sending a lot of packets, and they're sending them to many different IPs. That is our cue. So for the next query, we want to investigate that spike. So we're now limiting to traffic coming in on that customer interface on that device. We then group by the source IP and the ASN, and we group by the destination port. So what ports are they running to? And what are the source addresses and what are the source IPs of these packages that we are investigating? We're still looking at packets per second and the unique number of destination IP as the metrics. Here's the result of that spike. And in the red square, we are then seeing the ASNs that the sources of these requests are coming from. And that's where you start asking yourself your question, does that make sense? Are these ASNs the downstream of that particular customer? And you can use common sense, or you can go and look at your favorite tools that investigates customer and customer-provider relationships on the internet and check out, does it really mean that this customer has like Beeline as a downstream? And if it does not, then we are onto something. Note that we will also have the DDoS attack targets by looking at the source IP, the spoofed source IP. So in this case, we're like quite sure this is not good, and this customer, my customer B, is allowing spoofed traffic to enter the network. And then the tedious work begins. I'm gonna give them a call and say, hey, what's going on? And have a good conversation with them about what is going on. And here is what you need to prepare yourself, or you need to prepare your NOC, both to what to say to the downstream customers, and also your NOC, what to say if they're called, because that might happen as well, unless you are a fully BCP38 implemented network. Aaron, who has provided us with this method, has created a amplification peer response bingo card. And we do encourage you to maybe go print it and put it in your NOC and say, hey, you do not want to be these guys. It is a collection of some of the answers that he has gotten over time when he has called customers and said, hey, what is going on here? We don't have flow. We don't have no flow tools, so this can't be us. Or those are not our IPs, so this can't be happening either. So for those of you in here who runs a network where this could be a method to do, please consider doing it and help in the fight against DDoS. We've seen over time that the number of severe DDoS attacks are going down. Part of it is because the tier 1 networks have started out helping each other by doing this or similar things, really going dedicated after their customers and encouraging them or demanding them to up their game on security so we can join together in the fight against people who want to destroy the services that we all love and use on the internet. So please help out. And that concludes my, unfortunately, very short talk. Any questions, remarks, corrections?
Do we have any questions for Nina? Okay. So, thank you very much. Please join me in thanking Nina for a fantastic presentation.
All right. Thank you.
Thank you.